I am S.S. Selvi of second year ECE department. I am going to present a case study on the topic of Faraday mirror typed optical current transformers in electromagnetic fields subject. A Faraday mirror typed optical current transformer designed with a turned back optical path is proposed to overcome the harmful effects of linear birefringence inside bulk glass current sensing head, which can double the sensitivity and improve the state of polarization of the system output. The results shows that this design has a good suppressing effect on the degeneration of the polarization state of the output light, which has a certain reference significance on the performance improvement of the present bulk glass OCT and the development of the practical OCTs. Optical current transformers. Optical current transformer is an alternative to existing conventional current transformers, providing an advanced measurement solution for both metering and protection applications based on a cutting-edge patented optical sensing technology. Introduction. An accurate electric current transducer is a key component of any power system instrumentation. OCT is defined as sensors that directly or indirectly use optical sensing methods to measure electrical currents. MOCTs are another type of transducers which are highly immune to EMI. MOCT uses optical sensing methods to measure electrical currents. In the sensors, several properties of the signal carrier can be influenced. MOCTs are mainly based on Faraday effect. The optical current transformer basically consists of light source, fiber optic cable, polarizer, modulator, and electronics parts. There are different types of OCTs which are based on Faraday effect, based on interferometric principle, based on Bragg grating, based on micromechanical sensors with optical readout. Working principle. Magnetic OCT measures the electric current by means of Faraday effect as mentioned before. Faraday effects comprises of two principles: polarization of light. Polarization is a property of certain types of waves that describes the orientation of their oscillations. Polarization of light are mainly of three types: linear polarization, circular polarization, and elliptical polarization. Faraday effect. Michael Faraday discovered that the orientation of a linearly polarized light was rotated under the influence of the magnetic field when the light propagated in a piece of glass, and the rotation angle was proportional to the intensity of the magnetic field, which is intensity I is equal to I naught cos square of minus 45 degree. This diagram explains the Faraday effect, where d is the distance and b is the magnetic field. By considering this property, Faraday's mathematical equation is given by theta f is equal to mu naught V Ni. Mu naught is the free space permeability, I is the current to be measured, V is the Verdet constant, P is the permeability of the material, N is the number of turns of the optical path. The Faraday effect outlined in equation is a better format to apply to an MOCT because the rotation angle in this case is directly related to the enclosed electric current. This is the block diagram which explains the flow of light source. The MOCT consists mainly of electronic and optic parts. Light from a source enters an optical fiber polarizer which splits into two linear orthogonally polarized light. Light enters into the sensing head that includes a quarter wave plate. Quarter wave plate splits the two linear orthogonal waves into right and left hand circularly polarized waves. The applications of MOCT are The MOCT is designed to operate in a transparent manner with modern electronic meters and digital relays, which have been adopted for a low energy analog signal interface, makes the output signal insensitive to shock and vibration, most suited for outdoor type applications, example substations, accurate measurement of fault currents. Advantages: no risks of fires and explosions, high immunity to electromagnetic interferences, wide frequency response, larger dynamic range, low voltage outputs compatible with the inputs of the digital to analog converters, no need to use metallic wires to transfer the signal, and so simpler insulation structure than conventional current transformer. Conclusion: a new type of current transducer is introduced known as magneto-optical current transducer. This magneto-optical current transducer, what we had seen before, is a transducer that eliminates many of the drawbacks of the conventional current transformers. By applying Faraday's principle, this transducer provides an easier and more accurate way of current measurements. This MOCT is widely used in power systems and substations nowadays. Thank you.